So 5.2, as we go along, again, we'll do more and more stuff on the unit circle. You'll learn more and more stuff on it. But here's a nice warm-up from over a long weekend here. Why don't you try and change 320 degrees to radians, and please leave it in terms of pi. In other words, don't multiply the pi out. All right, let's see how you did. Well, we're talking about 320 degrees. And so we have to multiply by some form of 1 so that we don't change the value, just change the appearance. And basically we know that we want degrees to cancel, so degrees would be down there. You can pick any spot, remember, on the unit circle you want to get the form of 1 in relation to the unit circle. Probably the easiest one, though, is that 180 and pi are in the same location. It's just a lot quicker to use that one. So then, yes, the degrees do cancel. And if you simplify, I was going to say, I think a 20 comes out of there. So 16 pi over 9 is the radian version of 320 degrees. Okay. Any questions on that? All right. Arc length. Arc length will always be given as an S. Basically, because obviously A stands for area, so they couldn't use that. And so S, they use that, it's kind of curvy, so that kind of makes you think of the arc. And then R, obviously, as it says here, stands for the radius of the circle in whatever units it happens to be. This is a Greek letter that might be new for some of you. This is theta. And it's very important that it has to be the radian measure of the central angle. And the central angle, as you can see, is the angle that happens to be in the center. And so they were very tricky on how they named that one. So this is the center of the circle. It is an angle coming from the center. And so that's very simple. Basically what arc length is, I know we talked about it in geometry, but it's basically if I cut right there and straightened it out, how long would it be? Is really what arc length is asking. So it's a portion of the circumference is what it really ends up being. But this formula is actually quite simple. The one we had in geometry was much more complex. That's because it was dealing with degrees and not radians. So all you have to do to get arc length is take the radius times theta. Okay, that's all you got to do. Pretty straightforward. So right here it says determine the length of an arc that subtends a central angle. Don't worry about the subtends there. It just means it's out there. Of a 45-degree angle in a circle of radius 1. All right, so here we go, a radius of 1. And of course you can put that wherever you want. We know it's 1 centimeter. We know we have a 45-degree angle, so there it is. In other words, I want to know how long is that? Now, based just on your picture, do you think it's going to be longer than the 1 or shorter? Again, if I cut it out and straighten that out, do you think that is going to be longer than the 1? Or do you think it'd be shorter? Shorter there? Yeah, because I'd say that 45 is not that bad. That's pretty good for 45 degrees. Obviously, if you draw it poorly, you might get confused, but I think that's pretty close. And then how long is that? This one right here. 1 centimeter. I was just seeing if you realize that was the radius too. And so to do this, well, S equals, well, what's the radius? It's 1. Should I just take it times 45? No. We should convert 45 to radians. And 45 is probably one of them you know. You just took a quiz on it, so I hope it is. But in case you didn't, let's just go ahead and take a look. Degrees are down here. So the conversion we're going to use is that. And normally what I do is I just leave it in radians and I let the calculator take care of it. All right. And in fact, as far as this formula is concerned, could you leave it as 45 pi over 180? and put it in here and let the calculator do it? You probably could. But let's face it, I think we know that this cancels and that becomes a 4. And we know it's pi over 4. And here's really where you have to look. If it asks for the arc length in terms of pi, you would say pi over 4 centimeters is actually what you would write for this one. Does it say that in mine? Not really. So watch out for the directions. Let's just go ahead and get this particular decimal here. So the arc length, because I want to see if it's bigger than 1 or less than 1, is, let's go out a few decimal places. Again, you would have to look at the directions and see what they say. So you got to take 1 times pi over 4, which is really just pi over 4. And so you get point. Yeah, 0.785. That's what I think it is. And it'd be centimeters. So was it less than 1 or more? It was a little less. Okay. And we kind of anticipated that. And that's how long that would be. Pretty straightforward, really. It's a very nice formula. Radians makes it a lot easier. So let's determine the arc length on this one. It's a 42-degree angle. Uh-oh. And the radius is 8 centimeters. All right, so the arc length on this one. What do you think? Less than 8? More than 8? Right around 8? What do you think? Well, we just did 45 degrees and it was less, right? So I think this is probably going to be less than 8, probably by a considerable margin. S equals, the radius is 8. Now we got to go and get, so here's your degrees. Now they cancel. Again, if you're using your calculator, is there anything wrong with just putting 42 pi over 180 in that formula? There's nothing wrong with that at all. It's going to get you the right answer. But for those of you that are curious, what, a 6 comes out of there? 7 pi over 30, for those of you that like to simplify. And so basically it becomes, if you look at it the way I do, 56 pi over 30, and you can just type that in and find out what you get. Or find 7 pi over 30 and then take it times 8, whatever is going to work for you. And we find out that this arc length is approximately 5.864, he said. And what would the label be on that? Centimeters. If there are no questions, why don't you try example 3 on your own?